Many remotes died to bring you this information. Hi YouTube, hope you're all well. I've been messing around in the messy lab again. It's going to be another ANET A8 video, and what I've done is I've cobbled together a load of stuff from the internet, different ideas, and put them all together. What this is this a 3D printer safety shut-off system that works wirelessly. And the nuts and bolts of it are that if it detects a problem, it will shut off one of these wireless plugs, these 330 megahertz wireless plugs. And it's based on someone else's system that I saw, which is very similar, and I'll link it, which used a relay. So all I've done really is I've made the code a bit better. Added a few bits and pieces to the code, bells and whistles, and then instead of using the relay, I've made it send the code to shut off the plug wirelessly. I've uploaded two sketches, both of them work. One is for the wireless version here. I'll show you how to hack the remote control. That is the remote control. It's from Maplins, it's about £6 and it comes with the plug. So there's a sketch for that. In the sketch there are links to these pages of how to hack this, what the codes might be for your one if you haven't got this one, the libraries that you'll need. I've also improved the code a bit so that instead of using the DHT11 sensor, which I found to be not that great, it's using two NTC thermistors. One is seconded into the second hole in the hot end there, and secured with my little hot end cable support, which you can find on Thingiverse. And the other one is taped to the heated bed, the underside of the heated bed, and then secured. And they've been calibrated with a Steinhart-Hart equation. So what I've done is, in the code you'll see, in either of the codes, the relay version or the wireless version, it's got a Steinhart-Hart equation which basically works out, which you can use to calibrate the thermistor. Now I've calibrated the thermistor at 25 degrees C, 200 degrees C and 220. There's a link there to a calculator that you can change it to what you like, but basically you want the thermistor to be the most accurate at the area in which you're printing and which you're worried about. So that's what I've done. So there's two limits in the code. One is for the hot end and one is for the bed. The firmware will keep taking readings and it will take a moving average. You can vary how many samples you want in that moving average. You'll average them out on a rolling basis, and if that average figure goes above a specified limit, it will cut power to the printer. So if the bed goes out of bounds, it will cut power. If the hot end goes out of bounds, it will cut power, and if it detects smoke, it will cut power. So that's the idea, and without further ado, I will now give you an overview of the circuit. So first of all, I'm going to show you the test of the wireless version, and then I'm going to show you tests of the wired version, the relay version. Now I had a lot of trouble with the relay version, and I thought it was down to noise and all sorts of things, but actually it was down to a duff unit of relay unit. And what I found was that basically one relay failed, and then the other relay failed, and they both failed closed. And I don't know whether these are just bad units, but they're supposed to be 10 amps. And I know for a fact that I've got a 3 amp fuse in that power supply at 240 volts, and it's fine. So not sure what happened there, but if I was going to do it, I would use the wireless version. But as I say, I've uploaded both, so you can do what you like. So there's a little heck remote. I'm going to touch it, but signal line going to that side of the resistor just scraped off the solder mask, because that actually links back to that pin, second pin down there. And then the 5 volts and ground onto the battery terminals. Very, very simple. Tested it on 5 volts and it still works, so let's wire it up to the Arduino, put a bit of code in and see if we can get it working. So the printer's printing. Temp's 21. Switch is on. Without knocking the thermistor out of the board. grab the thermistor. Temp's 26. Switch has gone out with the noise from the printer. I think we'll call that a success. I'll do another test with it actually rigged up to the printer. I've set the bed to trigger at 27. So for now, prepare preheat PLA bed. It should turn itself off. And there we go. It's killed itself. So I think that's the better solution. Okay, so we're just wiring up the relay on the A-net A8, and I've got the board in there. That's a twin relay 10 amp board. This only produces or needs about, we could get away with 2 amp fuse in the plug there, because it's 240 volts. I've got a 3 amp fuse in there because it was getting a little bit of brownouts on a 2 amp fuse, but it didn't blow. But anyway, so that's 10 amp relay, well over spec. Got a 3 and a bit amp fuse in there, and the relay board is in there. I've put some rubber tape and what have you underneath it, and some screws to hold it in. And then I've used shielded cable here because we're right next to the power supply. Twisted shielded cable. I'll figure that out in a minute, but obviously keeping it away from everything in here, and just run it out. This is the trigger for the relay. So what we now got to do is take the live from what's onto there, go into one of the commons on the relay, then back out to there, so that the live will be subject to the relay being closed. So there we are, wired in. I'm going to change this bit of flex. It does say it's rated, but it doesn't look right. But anyway, for now, there we are. So comes into the switch is fused, comes out of the switch, goes into the common. Common, if there's a connection in the relay, goes back out to the power supply. And this is the control line for the relay, which I'm probably going to drill a hole in the front to keep it away from all the noise. Turns out the relay was bad. The relay that I bought from eBay was bad. Go figure. There's 2 relays on that board, so I've swapped them over. The first test. Lose power to the Arduino. Magic. So here we go. 203, 204, 205, 7, 8, 9, 10, 11, 12, 13, 14, 15, shut itself off. So the moral of the story is, do not trust anything that you buy off eBay.